All right, we made it to our third video on solve by completing the square. So each of these examples has just something a little bit different to look out for. If I were to give you guys this equation, do you notice anything about that? I notice that all three terms can be reduced down. They can divide down by 2 just to make the numbers smaller. So because this is an equation, we can go ahead and do that. We can divide everything by a 2, but I'm actually going to, because our leading term is a -2, and when we complete the square, we do want this to be a positive x squared and not a negative x squared. So why don't we go ahead and divide everything by a -2, all three terms. Now, because it's an equation, if we divide the left side by -2, we're going to divide the right side by -2. So, -2 x squared divided by -2 is a positive x squared. 12x divided by -2 is a -6x. -20 divided by -2 is a positive 10. And then 0 divided by -2 is still just 0. So why do we even bother doing that? Well, it's really kind of nice to get your numbers smaller if you can. If you can work with smaller numbers, this is going to be a little bit easier for us than this up here. So we'll take it. All right, so we have a new equation, x squared minus 6x plus 10 equals 0. We are solving by completing the square. So remember, we want this c value on the other side, so we're going to subtract 10 from both sides because we want to put in our own c value. Remember, we want to create our own. So we're going to get their c value out of our way, -10. But remember, we talked about how if we're adding in plus a blank over here, let's do the same thing over here because we know we're going to keep our equation balanced. All right, well, we know what we're doing. Let's go ahead and complete the square. So we take our b value, -6. We divide it by 2, which is -3. We're going to square that. That's what goes up here. So plus 9, and then add a 9 to the other side as well. Now we created a perfect square trinomial. This is factorable. Factors of 9 that add up to -6. Guess what? It's that -3 right there. But we remember it's -3 and -3. We can shortcut it and just say x minus 3 squared equals. And then on the right side, combine like terms, -10 plus 9 is a -1. All right, so we keep solving. We have our x alone right here, or we got an x right here. We locked down with the squared, so let's go ahead and undo that. Opposite of squaring is square root, so we're going to square root both sides. On the left side, that leaves us with x minus 3. On the right side, did you guys notice what we have here? We have a square root of a -1. Now, we learned in lesson 9.7 when we were solving with square roots that you can't square root negative numbers. So that means that there is no solution to this equation. Is it possible to have an equation with no solutions? I mean, these are parabolas. Don't they always have x-intercepts? So if you think about it, I'll just do a quick little sketch right here. Our original equation had a -a value, so now it's opening down. So our parabola probably looks something like this. And our solutions are x-intercepts. And if you have a parabola that never touches the x-axis, then this is what happens when you go to solve it. When you go to solve it and you can't because you're trying to square root a negative number, that just means it never crossed the x-axis. So that's perfectly normal, perfectly fine. We just put no solution for our answer. It's worth double checking to make sure that we didn't mess up, the math anywhere. What if we ended up with a -1 right here and it really should have been positive? So always nice to double check, but I think that looks pretty good, so I'm confident there. So I just wanted to show you what a no solution example looked like.